In this video we'll talk about dividing polynomials, and it's one of those things that can get pretty complicated pretty fast depending on what you're dividing by. So let's start with a simpler case. So let's say I'm dividing a polynomial by a monomial. And remember, a monomial only has one term. It only involves multiplication or division. So in this case we're dividing this polynomial by this monomial. And what we can do here is we can essentially break it up into three different fractions. So we can split this into 4x squared y over xy plus 2xy over xy minus y squared over xy. And then we can isolate these and look at them individually. Now we're dividing a monomial by a monomial, so we can use our exponent laws. So in this case, one of those x's cancels out an x, a y cancels out a y, so all we have is 4x on this one. In this case, in the middle case, the y and the x both cancel, leaving just a plus 2. And in the last case, just one of the y's cancels, leaving you with a y over x. And this would be as simplified as we can make this for now. Now let's take a look at what happens if I'm not dividing by a monomial. If I'm dividing by a binomial in this case, this x minus 4. I could break this up into 4 separate fractions, just like we did the last one. But then how do I divide x minus 4 into 2x cubed? How do I divide x minus 4 into 13x squared? So on and so forth. I don't necessarily know what to do with that. We don't really have a trick for dividing polynomials. So what we have is essentially long division for polynomials. What we'll do is we'll set it up just like we would for a long division problem. So we'll take x minus 4 and divide that into 2x cubed minus 13x squared plus 26x minus 24. And it's very important that we have each descending power of x in here. If there's one that's missing, go ahead and put in a 0x. It kind of stands as a placeholder, just like 909, 909. That 0 has meaning. It's holding a place. So here's what we're going to do. We're going to take a look at this x, and we're going to look at 2x cubed, just 2x cubed. What do I have to multiply x by to make 2x cubed? And I would think that is 2x squared. So now I'm going to multiply, just like we do for long division, on both of these terms. So let's take 2x cubed, or 2x squared times x, well, just x. That makes 2x cubed, just like we wanted. Okay, now we're going to have 2x squared times negative 4, which makes a negative 8x squared. And now we're going to subtract that off, just like we do for long division. Now be very, very careful with your signs here. So that's going to make that 8x squared positive. So our x cubed terms are going to cancel. Great, that's what we want. Alright, and then we're going to have essentially negative 13x squared minus a negative 8x squared, which is going to be the same as negative 5x squared. Now I'm going to bring down the next thing, just like we do for long division. Okay, now I'm going to look again at the x and this leading term that I have down here. What do I have to multiply x by to make negative 5x squared? Well, negative 5x. And then we multiply it through again, so we're going to take the 5x times the x, and we're going to take the negative 5x times the negative 4. So let's go ahead and do that. We'll have negative 5x squared, which is great, that's what we want. And then we'll have positive 20x. And then we're going to subtract this off. So the 5x squareds will cancel, leaving me with what looks to be 6x. And then I bring down the negative 24. And then again, I'm going to look at x and this leading term. And I'm going to ask myself, okay, how do I get from x to 6x? Well, multiply by 6. And then I'm going to multiply this through. So we're going to take 6 times x, which is 6x, and 6 times negative 4, which is negative 24. And then we're going to subtract this off, just like we do for long division. We get 0, which means that this quotient here, once I do this division, is equal to 2x squared minus 5x plus 6. And that's a bit of a long way of doing it, but this is one of the best methods to do this. There's one other called synthetic division that's a very similar approach, but this long division method will work.